Alright, so you're welcome back to the channel. It's always a pleasure to have you here and to go through another topic in mathematics. I'm Pendulum, I'm your tutor on this channel, and you're welcome once again. Today we are going into set theory. So like I told you in our last video, we are looking at a new topic, and set is one topic I've seen many students struggle with. So I hope you will stick with me through the next 4-5 videos that I will make on this topic. And as you know, I like to be very thorough, so I'm going to start from the grassroots of sets and cover as much as we can cover for this level. All right, so if you follow me, I assure you you will understand sets and understand it very well. As we go on, please, if you're new, subscribe to this channel and turn on the notifications bell. Ring the notifications bell so that you are notified whenever we put up a new video on any topic. All right, so let's go in. We'll be looking at set symbols and notations. All right, so let's start from the grassroots, and they're already on the board. To save our time, I didn't want to be writing it when I'm live, so I'll just explain them as basically as I can so that you understand what some of these things mean. All right, and probably when we do examples, you will see them more in practice. But we're looking at set symbols and notations. All right, so if you find this video helpful, do not forget to like it, drop a comment on the video, let me know if it helped you and if you like anything about the video, and then share this video widely. Share it to your friends, share it to fellow students, share it to your wards, your children, and share it anywhere you can. All right, that will be very helpful. So let's go. I think we have 12 points we are going to look at, so let's do this as quickly but as detailed as possible. A set is a collection of items with common characteristics. Alright, so that's the definition of a set. A collection of items with common characteristics. So I can have a set of fruits. Alright, is a collection of items and all of them are fruits. So that's their common characteristic. I can have a set of students. Okay, I can have a set of let's say Muslims, a set of Nigerians. That's a group or a collection of people that have a common characteristics, which in this case is that they are Nigerians. Okay, so that's a set, just a group, and they must have something, or they usually have something in common. Then sets are denoted by capital letters. So we represent a set by capital letters. If you look at the board, you see capital letters. That's what we use to denote a set. So probably if you want to write a set of Nigerians, you can use capital letter N to represent that set. All right, a set of students maybe that offer biology, you use capital letter B to represent the set, while the elements of the set or the members of the set, that is those things, those people that make up that set. For example, if you have a set of fruits, then all your fruits like your banana, your orange, your mango are the elements or the members of that set. All right, if you have a set of students, then the students in that class or in that school are the elements or the members of that set, and you represent the elements or members of the set by small letters. All right, so the set itself is represented by capital letter, whereas the elements of the set, the members of that set, are represented by small letters. Take note of that. Then 3, sets are enclosed by curly brackets. So when you want to write a set, you use a curly bracket. That's something something like this. Okay, you use a curly bracket. Okay, you don't use your normal parenthesis, you don't use a square bracket, you don't do something like this. This is not for sets, please. Or you don't do something like this with your square bracket. No. Okay, you use a curly bracket to enclose or represent a set. Very important to take note of. Then another very important thing in set, the order of arrangement of the members of a set or the element of a set does not matter. So whether I write, just like in this case, A, B, C, D or C, A, B, D, it doesn't matter. Alright, they are the same thing. So whether I write a set and I say 1, 2, 3, or I write another set and I say 2, 1, 3, these two sets are the same thing. The order of the arrangement does not matter when it comes to sets. Alright, so I hope that's clear. Now, I told you something about elements or members. If you say something is an element of a set, it means it is in that set. It is part of that set. A member of a set is a thing, a person, a number, a letter that is part of a particular set. So how do we denote that mathematically? We use a kind of like an E, but it's like a curved E. Yeah, that's the sign. This sign here. This sign means that it is a member of. That this is a member of this. So for here now, I can say if this set is the set A, for instance, this set, I can say 1 is a member of set A. What this means is that the number 1 is a member of set A. Alright, and if you look at set A, there's 1 in it. So this is the symbol for saying is a member of, or it belongs to, or is an element of. That's the symbol. Then if you want to say it is not an element of or is not a member of, you just cross it out. So in this case, I can say, okay, 5 is not an element of A. 5 is not an element of A. So that's the symbol here. That same E, curved E, you what they call this? Slash it out to show that this is not part of this. 5 is not a member of A. It's not an element of A. Alright? Very important to take note. Then the number of elements in a set is written as NA. The number of elements or number of members in a set is written as small letter n and then A. So for instance, the number of elements in set A here, I'm still dealing with this set, the number of elements in set A here, as you can see, is 3. So the number of elements in A is 3. So we write it like this: number of elements in A. Okay, this is how we write it: NA. The number of elements in set A, we write it like this, and in this case, it is 3. Alright, I hope you're taking note of this. Very important. Number 7, two sets are said to be equal if they contain the same elements. Alright, so remember I've already stated that the order of arrangement does not matter. So in this case, we have that P is A, B, C, D, set P, and set Q is C, A, B, D. We say they are equal, the two sets, if they have the same elements or members. And as you can clearly see, there's A here, there's A here, there's B here, there's B here, there's C here, there's C here, there's D here, there's D here. So they are equal. These two sets, P is equal to Q. Forget about the arrangement. It does not matter in sets. I hope that's clear. Alright, number 8, an empty set is a set that has no element or member in it. Alright, an empty set has no element or member in it. That's why we say it's empty. It's just on its own, it's there. Okay, it does not have children. Let me put it like that. An empty set does not have children. So this is the symbol, just an open curly bracket. This is the symbol for an empty set, nothing in it. Alright, or an O that is crossed out. But this is the most commonly used one for an empty set. But if any of this you see, just know it means that that set has no element. For instance, an example of a set that will be empty is, let's say, a set of that contains 5-year-old children who are in the university. A set of 5-year-old children in the university would be an empty set, right? Because there are no 5-year-old children in the university. So that's an example of an empty set, okay? Or a set of people that will live forever. That should be an empty set because I don't think there's anybody that will live forever as far as we know. So that's an empty set, no element or member. Then you also have a finite set. I've talked about an empty set, we've said equal. Now a finite set or a finite set. When we say something is finite, it means it can be counted. Okay. When we say something is finite, let me stick to that. It means it can be counted. It is countable. So a finite set has elements or members which can be counted. It has elements or members which can be counted. So for instance, the set of even numbers below 50 is a finite set because it can be counted. The set that contains a set of x that is even numbers below 50 is 2, 4, 6, 8, 10, 12, 14, 16, 18, like that till you get to 50. No, till you get to 48 since it's below 50. It's finite. We can write all of them out and count them to have their number. Alright, so that's a finite set. If I write a set of the players of a particular team in a football match, it's finite because they have a particular number. Those who are starting must be 11. Okay, so that's a finite set. We can count them. The reverse or the opposite is an infinite set. An infinite set is uncountable. That's the members or the elements in that set is what? Uncountable. You cannot really count the number, or you cannot count them, the elements of that set or the members of that set. For instance, the set Y, which is a set of all even numbers, is uncountable. It's an infinite set. Even numbers keep going, keep going, keep going. I don't know where it ends, and I'm very sure you don't know as well. So it's a finite set. Another example of a finite set is all odd numbers. Alright? The set containing all odd numbers is also an infinite set. There is no end to the members or the elements of that set. That's a finite set. Then number 10, we have a unit set, also called a singleton. We have a unit set, which is also called a singleton. Now when we say unit, of course, unit means one. So a unit set is a set that has only one element. A unit set is a set that has only one element. For example, B is a set of the current presidents of Nigeria. Obviously, Nigeria can only have one president at a time. So B is a unit set or a singleton because it has just one president at a time. Alright? So that's a unit set, just one element in it. Okay? And then number 11, two sets are disjoint. We say that two sets are disjoint if they have no element in common. You know what it means that two things are disjoint, right? This is one set, this is one set. Nothing is linking them. They have no elements, no members in common. Okay, so these two sets are disjoint. Why? They have no elements in common. For example, if A is a set of even numbers, so in A I have 2, 4, 6, 8, and B is a set of odd numbers. I have 1, 3, 5, 7. This is a disjoint set. There's nothing common between A and B. There is no number that is both even and odd. So there will be no common elements or members between them. And then we have the difference of two sets. Now the difference of two sets is represented as the first set minus the second set. That's this. Difference of two sets, we represent it as the first set minus the second set. And it simply means elements or members that are in the first set which are not in the second set. Elements or members which are in the first set but not in the second set. So for instance, if this is set A, 1, 3, 5, 6, 8, and set B, 2, 5, 7, 8. These are two sets. Now, the difference of A minus B, that's the difference of B from A minus B, will be elements in A which are not in B. And the elements which are in A and missing in B are 1, 3, and 6. There's no 1 in B, there's no 3 in B, there's no 6 in B. So A difference B, or the difference of B from A, is 1, 3, 6. Then on the other hand, the difference of A from B, or you say B difference A, are the elements that are in B which are not in A. Now it's the other way. Elements in B which are not in A. And that's 2 and 7. Okay, there's no 2 in A, there's no 7 in A. So this is B difference A. Elements in B which are not in A. This is A difference B. Elements in A which are not in B. Okay, so this is quite clear, quite straightforward. So these are the basic symbols and notations that we'll see in sets. Alright, so we'll go further and look at some other things you need to know about sets as we start creeping into solving questions on sets. Alright, so I think we'll stop here for this video so it doesn't get too lengthy, and then the next video we'll look at operations in sets. So let this just be an introductory video into set theory. Going further, we'll look at operations on set. We'll look at union, intersection, complement, subset, and all of that. How can you use them to solve questions? Then we'll go into Venn diagram later. Alright, so this is your assignment for today. List two examples each of disjoint sets, finite sets, empty sets, unit sets, and infinite sets. So that's your assignment. Try it for your own good. Send it to me on WhatsApp so that I can cross-check it, or drop it on our Telegram community or YouTube community here. Alright, so just give me two examples of sets that are disjoint, that are finite, that are empty, that are unit sets, and that are infinite. Two examples each. Alright, so thank you so much. I hope you enjoyed this video, and I hope these were very understandable. These are the basics, so if you get this right, you have a good foundation to build on when it comes to sets. Like this video if you enjoyed it and it helped you. Please drop your comments. Let me know exactly what you learned from this video, how you like this video, and if there are things you want me to do more of. Alright, then share this video. That is very important. Let your friends, your colleagues, your children see this video, because I know it will help them. Alright, now I'll see you very soon in another video. Do subscribe to this channel if you're new, and ring the notifications bell so that you don't miss out on our videos. Thank you so much. I keep telling you, mathematics is simple, mathematics is fun. Just keep learning, keep studying, and you will see yourself doing well in no time. I'll see you very soon. Bye.